Hey guys, we're going to talk some more about equivalent fractions. Earlier this week we talked about taking fractions like 1/2 and multiplying them by another fraction that's equivalent to 1. So 3/3. Ooh, that's equivalent to 1. So then we did 1 times 3, which gave us 3. And then 2 times 3, which gave us 6. So we can say that 1/2 is equivalent, sorry, that's my dog. 1/2 is equivalent to 3/6. Now the most important thing to remember here is that rule for making equivalent fractions. Whatever we do to the bottom, we must do to the top. So if you're going to multiply the denominator by 3, then you've got to do the same thing for the numerator. Let's do another one real quick just to refresh ourselves. How about 2/3? We could do 2/3, and to show that 2/3 is equivalent to 4/6, I can say, well, I know that 4 divided by 2 is 2. So 2 times 2 is 4. And then 3 times 2 is equal to 6. So I know that 2/3 is equivalent to 4/6. So with this rule, we know that I can multiply any fraction by any number to make an equivalent fraction as long as I do the same thing to the top that I did to the bottom. Sorry. Alright, but in this next step, application, if you'll remember, inverse is the opposite. So we're going to do the inverse operation of multiplication, which is division. And we're going to apply the same rule. We're going to see, can we divide fractions but follow the same rule of whatever I do to the bottom, I must do to the top. Now if I'm going to do that, we have to talk a little bit about factors. Let's look at this 4/6, for example. The factors of 4 are 1, 2, and 4. And the factors of 6 are 1 and 6, 2, and 3. Now if I have to divide both of those numbers by the same number, which number could I do that with? Hopefully you saw that both 4 and 6 have a common factor of 2, so I could try and divide each number by 2. As long as I do the same thing to the top as I did to the bottom. 4 divided by 2 is 2, and 6 divided by 2 is 3. So I can say that 4/6 is equivalent to 2/3. Now let's just take a minute, and I'm going to erase. And let's see if we do the inverse operation to check our work, will we be right? So let's change colors here. So if I take 2/3, and I'm going to see if it's equivalent to 4/6. If I multiply 2 by 2, I get 4. But let's check the denominator. If I multiply 3 times 2, do I get 6? Yes. So I still know that 4/6 is equivalent to 2/3. Alright, let's try this again with 6/8. If we have to do the same thing, let's look at their factors. 1, 2, 3, and 6, as I just listed. And then for 8, we have 1 and 8, and 2 and 4. Again, what factor do they have in common? Well, they have 2 in common. They also have 1 in common. But if I divide each of those numbers by 1, what is it going to get me? Let's just try it real fast. 6 divided by 1 is 6. 8 divided by 1 is 8. So I can say that 6/8 is equivalent to 6/8, but did I change the fraction at all? No. So even though 1 is a factor that they have in common, it really doesn't work in that situation. So let's try 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. So I can say, once again, that 6/8 is equivalent to 3/4. Now, another thing to point out here is that common factor 2, if we look at the numbers 6 and 8, what do we notice about those numbers? They are both what kind of numbers? Even numbers, right? And we know that all even numbers are divisible by 2. So I really didn't have to list out the factors to go ahead and divide by 2, because if they're both even, I know I can do that. Okay, now let's look at these two. Let's start with 3/12. Notice that they're not both even numbers. 12 is an even number, but 3 is an odd number. But just because one's odd and one is even, that doesn't mean they don't have factors in common. So let's look at 3. 1 and 3. Now 3 has exactly 2 factors, so it is a prime number. And then we've got 12. 1 times 12, 2 times 6, and little bitty 3 times 4. There we go. All right, so of course they have their 1 in common, but then you'll notice that they also have 3 in common. So we can divide. Ritzy is so silly. Each of those by 3. 3 divided by 3 is 1. And 12 divided by 3 is 4. Ritzy thinks you guys are doing a great job. All right, so we can say that 3/12 is equivalent to 1/4. And if you'll notice, we're still following our rule, we're doing whatever we do to the bottom, we do to the top. And 3/3 is still 1 because, let me erase this. Because if we take anything, any number, and divide it by itself, like if I take and divide it by 1, I get the same number. It's not changing the number at all. Okay, now let's look at 5/15. I notice that I have a 5 and that 15 ends in a 5. And we know that any numbers that end in a 0 or a 5 are divisible by 5. I could also list out the factors. If I didn't notice that, I'd get 5 is 1 times 5, and 15 is 1 times 15, and 3 times 5. So here they have the 5 in common. So I'm going to divide each by 5. Whatever I do to the bottom, I must do to the top. 5 divided by 5 is 1, and 15 divided by 5 is 3. So, changing up that color one more time, because I love the colors, we can say that 5/15 is equivalent to 1/3. Alright, now let's look at 3/8. If I list the factors of 3, I've got 1 times 3. Factors of 8 are 1 times 8 and 2 times 4. If you'll notice, the only thing they have in common is 1. And we discovered earlier that when you divide a number by 1, you're only getting the same number. You're not changing it at all. So if we can't do the same thing to both numbers, then we can't do anything at all to change 3/8. If I try to divide 8 by 2, and then I try to divide 3 by 2, I'm not going to get a whole number. So this wouldn't work. Okay, so 3/8 I cannot change with division. So there might be some fractions that you can't change with division, and we'll talk about that a little bit later. Now let's look at 5/12. 1 times 5, and then 12 is 1 times 12, 2 times 6, 3 times 4. Again, only thing they have in common is 1, so I cannot use division. Now we talked about earlier that we can use multiplication, any number we want, anytime, as long as we follow that rule. Whatever we do to the bottom, we must do to the top. But division doesn't work that way. Division, you have to be able to have two numbers that share the same factors. In this case, they do not, so we cannot use division. Alright, now I want you to take a couple seconds and see if you can do this on your own. I'm going to give you 10/12. See if you can use division to make an equivalent fraction. And then I'm going to give you 7/28. See if those fractions are ones that can be divided, and if they can, what can you make? So take a second, pause the video, see what you can do, and then unpause and we'll talk about it. Alright, let's talk about 10/12. First of all, the first thing I notice is they are both even numbers. So I know I can divide them both by 2, but, oops, if I list out these factors, 10, 1 times 10, 2 times 5, and 12. 1 times 12, 2 times 6, 3 times 4. They have their 1 in common, and they also have 2 in common, which, as I said a minute ago, they're both even numbers. All even numbers are divisible by 2. So 10 divided by 2 is 5, and 12 divided by 2 is 6. So 5/6 is equivalent to 10/12. Alright, let's change up the colors. And we'll try 7/28. Now, 7 seems like it's not an easy number to work with because it's a prime number, but we're not going to let that fool us. We've got 7, 1 times 7, and 28, 1 times 28, 2 times 14. See, can 3, no, because 3 times 9 is 27, so 3 is not a factor. Can 4, no, well, can it? 4 times 6 is 24, so an additional 4 would be 4 times 7, and then 5 times nothing makes 28, and then 6 times nothing makes 28. So here I go. I've got my 1 in common, and I've got 7 in common. So if I divide each by 7, 7 divided by 7 is 1. 28 divided by 7 is 4. So 7/28 is equivalent to 1/4. And a reason that we like to make equivalent fractions using division is because it's a lot easier for me to envision 1/4 of a pizza being eaten rather than telling me 7/28 of a pizza has been eaten. It's a lot easier number to deal with and visualize. Alright, here's 2 more to practice on your own. Go ahead and pause the video and then we will work them together. Alright, I look at 12/15. They're not both even numbers, so I'm going to think about their factors. 2 times 6, 3 times 4. And once I get to a point where I'm comfortable with factors and knowing them, I don't have to list them all out. But right now, we're still practicing, and so I want you to visualize what it is we're doing. Alright, so they've got 1, and they've got 3 in common. So I'm going to divide each of them by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. So if you got 4/5 is equivalent to 12/15s, you are absolutely correct. Okay, let's see what we can do with 12/24s. first thing I noticed, they're both even numbers. So what can we divide by? 2, right? So I can do that. 12 divided by 2 is 6, and 24 divided by 2 is 12. But what do you still notice? 6 and 12 are still even numbers. So I could divide them again by 2 if I wanted to. 6 divided by 2 is 3, and 12 divided by 2 is 6. Okay, not both even numbers, but what do you notice about the relationship between 3 and 6? I notice that 3 is 1/2 of 6. So we can say that 12/24 is equivalent to 6/12 and is also equivalent to 3/6 and is also equivalent to 1/2. If you got any of those answers, you were absolutely correct. But let me erase all of this and show you what would happen if we were looking at the factors. Okay, factors of 12. 1, 12, 2, 6, 3, 4. All right, 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right, so if we look at the factors they have in common, change color so we can see this. They've got 2 in common. They've got 3 in common. They've got 4 in common, and 6 in common, and 12 in common. So I could divide by any of those numbers as long as I follow that rule. Whatever you do to the bottom, you must do to the top. In order to get a half, you'll see that we just had to divide by 12. 1/2. Okay. In order to get a different one, we can divide by 4. That's 3/6. That's another one we got. And we can divide by 6. Did they have 6 in common? Yes, I circled that. 2/4. That's another one we didn't find, but is also equivalent to 12/24. Awesome job.